Hey guys, welcome back. Hope everybody had a good Thanksgiving. What better way to kick off your first planning after Thanksgiving than with a STEM Talk Tuesday? Today we're actually going to be focusing on communication, which is one of the 4 C's that the STEM Certification Committee wants us to focus on really heavily. Okay, so we're just going to be looking at how we can enrich students' learning using student-produced content or student-generated content. So the reason why we're doing this, first of all, is because we want our kids to learn and retain, but also we're trying to get STEM certified. And their expectations are that students produce the content and that students lead the discussions about their learning. When they come to the schools to do our walkthroughs, they're not going to talk to any teachers besides, "Hey, how are you?" The kids are going to be pulled out into the hallway, or they're going to ask them at their tables or their seats what they're doing, and to kind of talk through that engineering and design process and to use the vocabulary word that comes along with that. They want to see math vocabulary in the science classroom and science vocabulary in the math classroom. So they want to see those cross-curricular connections and the STEM vocabulary. And they're not going to ask you. They're not going to ask us to submit lesson plans. They're not going to look at a binder to see if, we came to STEM Talk Tuesday. They're going to be talking to the kids, which in the end is, the telltale sign of whether or not this has been really well implemented. Okay. Also, I hope what we do today, and what we do in the future, I hope you get more bang for your buck out of your STEM lessons, and that the kids have a reflection piece where they go back and they kind of synthesize all of their learning. So student-generated content are not just PowerPoints. We tend to fall back to PowerPoint because that's what we know how to do, but we kind of forget that the kids know how to do a lot of really cool things. So they can actually make videos. They can use Screencast-O-Matic like I'm doing right now to even narrate their PowerPoint or to make a webcast. They can upload their videos to YouTube. ThingLink, if anybody's ever used that, you put a picture behind it and they can use this to keep track of their research, or they can actually write on these, and it just basically allows them to link other images and other content to a picture. So I'm reading a book right now, and it's talking about how everybody got TVs in the 1950s. So I might take a picture of the blue glow coming from a house and talk about, historically how the porches shrunk, how people stopped walking as much, how people stayed inside more, and the effect that had on people's health. So you could do something like that just with a picture of a blue glow coming out of a living room. They can make flyers and infographics. I use Canva a whole lot, and a lot of my kids have used Canva. So last year, a student made this. We did food trucks right before we went home for summer break. They had to create healthy, environmentally friendly menus. And so she actually made this on Canva, and she had a whole menu going, okay, as you guys can see. And of course, they on their little solar truck, they had little solar panels. It was really cute. Excuse me. Any kind of citizen science data, if they measure or collect something and put that on, create a spreadsheet and enter that information and create a table, or if they even just draw their own table, that's student generated. Pieces of art are student generated works. If they create a play, if they make a storyboard, if they make a picture book, if they use this, or if they create some kind of display. All of those are student generated, and there's a million more. I was just trying to give you guys some ideas that are not PowerPoint. But what we are going to do is we are going to make these storyboards about our engineering and design process as we go through a STEM lesson. One of the schools that I met and talked to at the STEM conference talked about how big of a role this played in helping their kids' learning. At first, of course, they were doing it just for like, oh, look at what we've been doing for the STEM certification committee as they walked through. But as they trained their kids to talk through the storyboards, they saw that it was really rewarding, and the kids realizing how all the pieces fit together, and they were coming to better conclusions at the end. So something that was supposed to be cutesy, something that was supposed to just kind of highlight a couple of their lessons, has turned into something that they do all the time, because the kids come back to it and they talk through it and they see it in the hallway all the time, and it's a constant reminder of a standard that they've covered. So storyboards are a display board that outline the engineering and design process in your lesson. And it allows, students it can be something you reuse over and over, or it can be a one-time thing. But the student work is displayed, and each step in the process is highlighted. And then you can add your own vocabulary in there, and then at the beginning, of course, of your storyboard, you want to, state the problem and what the kids are supposed to learn. The kids can make them individually. They can do it, you can do it in your classroom, or you can work as a content area and post it, outside in the hallway. But of course, we want to highlight the cross-curricular aspects of what we're doing, and also the kids using the vocabulary from our content, and being able to talk through the engineering and design process. So we've got 3 layers of things going on, but this one thing is going to help us meet all of those objectives. Okay, so this is an example of an engineering and design process board. This is not how it looks in my mind, but this is a pretty good, replica of it. It can be something as simple as taping up bulletin board paper, using masking tape, and dividing it into the sections for our engineering and design process, and just having the kids tape their paper to it. So, of course, over here you start, and you're going to state your problem. Okay, so I would actually put my problem right here. And then you can add the pictures of what your kids actually working, but also their papers, like where they actually created the data, and displaying it here. And then at the end, okay, they will have something where they have some sort of student-generated product, or some sort of written thing of basically saying, through this process, I learned. And of course, we want them to use our vocabulary from our contents. Okay, so coming back to the storyboarding, the benefits for you are that the kids are going to be using your vocabulary. They're going to be writing over and over again those vocabulary terms. They're going to collect the data, and they're going to make connections between math, science, hopefully social studies, and science and math and language arts. All these things are going to come together on this board. I think if they stand back and look at all their data, they can actually start to draw some conclusions. It also allows them to step back even further from their own data and see class data. So recently, 8th grade science did a project with convection currents, and everybody's line graph looked pretty much the same. It started off where up top it was cool, but as the light stayed on longer, the temperature went higher and higher. And then when we insulated them, the temperature got even higher over time. And everybody's data had the same trend, even if they had different numbers. So from that, we're able to draw those conclusions about why we insulate our houses. And then they also could more clearly communicate how the STEM lesson related to our standards. So if you go back to the standard and say, what is a convection current? The kids were able to really articulate what that was a lot better than in the past when we just talked about it. And me standing up at the board and saying, this is a convection current, here's a cool picture, and moving on. And it gave that real life meaning to convection currents. Okay, so at the end of the day, how does this help with your bottom line? You may not be into STEM, you may not be into all of this, but at the end of the day, it has a benefit for you. And one of the biggest benefits is using that vocabulary, is coming back to that standard and having to basically tell how your data, how your project showed that standard. And it gives those kids an anchor point to come back to that experience. You're not just telling them something and expecting them to believe that it's true, but they're actually making their own truth, and therefore they will remember it a little better. This standard isn't something that was meaningless to them. They actually got to make the standard. So it's really performance-based. And at the end of the day, we all know that that's what the kids are going to remember on the test. If they're used to looking at data and drawing conclusions, they'll be a lot better at it on the test. If they're used to thinking and having to write about all of these connections, then on a multiple choice test, we should be critical thinkers. We should be able, if we can write about things and we can discuss things, surely we can take a multiple choice test a little better. And even if we can't, what if we're just thinkers? So hopefully at the end of the day, this brings you back to if you're losing the meaning of STEM in the building, and the building process is a little out of hand, it's not your favorite thing to do, I think coming back and making these storyboards will re-anchor you in your standard that you were trying to get at to start with. And even if some kids didn't get done, even if some kids kind of goofed off or didn't pay attention, they have that class set of data to come back and look at, and they can still do the analysis, and they're not left out of drawing conclusions. So if you have any questions, let me know, and I can't wait to see your guys' storyboards. So the next set of STEM lessons and STEM Spotlight months that we do, we are going to make these storyboards, and science will be up first, so I'm excited. Thanks. Bye.